Question 6b asks, how long will it take for the dose to reach the low level of 52 milligrams? So at this point, I am going to rewrite the equation y equals 250 bracket 0.95 to the exponent of x over 60. So they're telling you this value 52 milligrams. So that is the amount of drug. That means that is the y value that they're telling you. And so based on that information, you already had your exponential equation from the previous question. And so I'm going to sub y equals 52, and that's going to help me find the x. So I'm going to plug it in and I get 52 equals 250 bracket 0.95 x over 60. I'm going to do BEDMAS backwards as an initial step. So I'm going to divide both sides by 250 and I will get 0.208. And that is the exact value equals 0.95 bracket x over 60. So this is the problem that we've dealt with 3 ways of solving. And for this question, I cannot do the match the base method, and we've done all we can do with the BEDMAS backwards method. And so that leaves us with trial and error. And basically at this point, you are free to do a trial and error and try to figure out the closest x you can get. Okay, I'm going to leave it at that, and you're going to get your x value, right? So this is something that, but for those who are interested, I'm going to teach you or show you at least the log way. In terms of assessment, it's safe to say that it's the 3 methods of solving that we're going to focus on, but I'm showing you this log way as an alternative to the trial and error for those who really don't like doing the trial and error way, because it's hard to tell when you're right, or if you're close enough. So with that in mind, I'll show you this side note that I have provided you. And this kind of side note was made as I was referring to the Khan Academy logarithm video, and I put in my own input. And so the main idea is that logarithm is like taking the inverse of the exponent, and this is more heavily done in grade 12. And so for this example, 2 to the exponent 3, we know that the answer is 8, right? So the base of it is 2, and I could say the input, the exponent is 3, and the output is 8. What logarithm does, is that if you have a log and you have a log with a base of 2 and you're taking it of 8, the answer to that is 3. So what you're really saying is 2 to the exponent of what equals 8? Well, the answer to that is a 3. And see how there is a correlation between the exponent and logarithm. And the way I look at it is the base stays as a base. So see how the base stays as a base when you have the exponent form or the logarithm form. Meanwhile, the output, the answer, the output becomes the input. Okay, the output becomes the input because this is what I am taking it of. And then part 3, the input becomes the output. This input as the exponent now becomes the output. And so if I have 4 to the exponent x is equal to 64, I know that the answer is x equals 3. So when the question is, what is log 4 64 equal to, that is really saying 4 to what exponent is equal to 64. And we're playing around with this. But if I was just working purely with log, what I'm doing is on the calculator, you're doing log 64 divided by log 4, and x equals 3, okay? And so 4 to what exponent equals 64? Well, a 3. 10 to the exponent what equals 1 million? Well, you can do the guess and check way, or you can do the matching the base method. Well, x is equal to 6. Well, if you put a twist in terms of the log way, which is like the exact way, it's like you're doing log of you have log 10 and then the input of a million, and you can reword it by saying, oh, log a million. I'm missing a 0 there. Log a million, 1 million divided by log 10 is equal to 6. So it's helpful to look at some of these smaller examples to see how exponent and logarithm is emphasized. In grade 11, don't worry about the log. It's only for those who are interested that would want to do the trial and error way. But you do have to know this for grade 12. I'm not assessing you on it for grade 11, but these are all the FYIs. So in terms of our problem, again, I can do it the trial and error, but if this is this is basically how I look at the exponent equation. I have my input, I have the base. So I have the base, I have the input, and I have the output. So when I rewrite it, I have log, my base stays as the base, so it's this little number, and my output becomes the input, so I put it in there, and my input becomes the output. So see how I'm color coding it so you can follow along? And so if you want to put it in the calculator friendly way is that you're going to do log 0.208 divided by log 0.95. And with that, you would get a certain value, right? And with that value, you're going to times by 60. So I can get rid of these 60s on the right side. And I have x equals all of that. So when I put all of that in the calculator, I get a more exact answer. And this is the approximate answer I get. The reason I have to show you this calculator friendly way is because on the calculator, it assumes a base of 10 when you're taking the log. So even though on your calculator, it doesn't say it, it is really log of 10 is what you have on your calculator. And so that's why we have to kind of manually make it work. And this is kind of the conversion that we can be doing to make it work. Okay, so back to our question, just rewriting it. So I have log. My base becomes my base here, so 0.95. My output becomes the input, so that's 0.208 is equal to my input becomes the output, and this is what I have. So to do my calculator friendly way, I have to do log 0.208. That becomes a part in the numerator divided by log 0.95 is equal to x over 60, just remains like that. Now it's just a matter of getting that x by itself, and I get this. And so putting that all in the calculator, I will get x is equal to, basically you're putting in the calculator log 0.208 divided by log 0.95, times that by 60, and you will get 1836.8 minutes. So what does that mean in terms of my question? I'm going to have a therefore statement. Therefore, it will take about 1837 minutes to reach 52 milligrams. Question 7a, carbon-14 has a half-life of 5,730 years. Determine the percent of the original carbon left after 1,000 years. There's a disclaimer that says if no initial amount is given, assume 100% is the initial amount. So that half-life, that is telling me that B is equal to a half. 5,730 is the period it took for my carbon-14 to reach its half-life. P is equal to 5,730. Remember our graph data at the beginning when I was introducing it? So 1,000, that is my specific X value. Meanwhile, I'm saying that if no original amount is given, then you're going to assume A is equal to 100. Why? Well, you're kind of assuming that, you have 100%, right? And that's kind of like looking as 100 grams, but in this case, we'll just say 100%. So we have 100. So setting up our equation, we have y is equal to, A is 100, B is a half, and you have x divided by p, and we said that was 5,730. I like to indicate what my variables are. My x is the time in years, and meanwhile the y is the amount of carbon. I need to sub x equals 1,000. Why? Well, it had said determine the percent of original carbon left. That means I need to find out my y. So I will have y is equal to 100, bracket a half, x not x divided by 1,000 divided by 5,730. Y is equal to, put that all in your calculator. So you're going to do 0.5 to the exponent of bracket 1,000 divided by 5,730 times that 100. And you're going to get an approximate value of 88.6. And make sure when you're writing your therefore statement, you're trying to make sense of all of this. Basically, you started off with 100% and you're left with 88.6%. And pay attention to the wording of the question. It says how much of, determine the percent of original carbon left. That means I can write the 88.6 as is, point value, instead of me having to do any subtractions. Because like, for example, what if they said how much of the carbon was used up? Then you would have to subtract 100 minus 88.6 to make it work, right? So just make sure you have a full understanding of what's going on and then write your therefore statement. So therefore, 88.6% of the original amount will remain. For question B, it says some prehistoric cave paintings were discovered in a cave in France. If the paint contained 48% of the original carbon-14, estimate the age of the painting. So that means directly I have y equals 48. That is how much I have remaining, right? And then estimate the age means I need to find the x value. And so I have my original equation, which is y equals 100 bracket a half times x over 5,730 from before. And I'm going to sub y equals 48 this time and solve for x. So I have 48 is equal to 100 bracket a half x over 5,730. So I'm going to basically do BEDMAS backwards so I could just get the bases by itself. So I'm going to divide by 100 on both sides. I am going to get 0.48, the exact value, is equal to a half with an exponent of x over 5,730. At this point, you notice that the left side is about 0.5, on the right side it's a half, and you can do your trial guess and check from here, right? I'm gonna stick with the log way just so I'm getting like a precise answer. Remember, with the log way, I'm gonna write log. My base becomes the base. My output becomes the input. My input becomes the output. Not done yet. I have to do one more step. I'm going to rewrite it like log 0.48. That part is going to be part of the numerator. The base part is going to be part of the denominator. And I have x over 5,730. I will get x is equal to, do log 0.48 divided by log 0.5, times that by 5,730. On both sides, and you will get x is approximately equal to 6,067.5 years old. So need to write a therefore statement for any word problem. So I get, therefore, it is about 6,068 years old. What this painting that they discovered, and because the painting contained 48% of the original carbon-14, the painting is 6,068 years old. Number 8, health officials found traces of radium F beneath the local library. After 69 days, they observed that a certain amount of the substance decayed to 1 divided by square root of 2 of its original mass. Determine the half-life of radium F. So let's break that down. So after 69 days, that means they're talking about a specific situation of x equals 69 days. So they observe that a certain amount. What does that mean? That means you're dealing with the A that is unknown. I have a half-life of, so B is equal to 1 over 2 is what I know. They're telling you determine the half-life of radium F. So that's also telling me that I need to find the P. At this point, we don't know how long it takes for the radium F to become half its original amount. So now we need to interpret the A part and this funny part over here. So A is equal to unknown mass. So then we could use a strategy that we used before. We could either set A as 100% or as A is equal to 1, depending on what makes more sense in this situation. Our Y value, we know that this new mass is going to be Y equals something, and it's going to be 1 and square root 2 times the original mass, because remember, of means multiplication. I have 2 of these Skittles. That means I have 2. I have 5 of the dozen donuts. That means I have 60 donuts, right? This in 2 ways. One, if I had the yellow highlight example versus if I had the blue highlight example. So I have 1 over square root 2 times it by 100%. That's my first version. Meanwhile, my second version is if I do 1 over square root times 1. And so I would simply have Y equals 1 over square root 2. Well, between the two examples, what's an easier way to look at it? And as long as you're paying attention to the units and you know at the end of the day what I'm saying it in terms of, like percent, or is it like 1 gram, like you're making your own unit so that it works. And so between the two, the blue highlight looks a lot easier in this case. And so we're going to stick with that. And at the end of all this, I want to find out how long does it take to get to half-life. So at this point, I'm going to start writing my equation down. And remember, I usually plug in the A, B, and the P first. So I have Y is equal to unknown mass, so I already set that value, right? So that's a 1. My B value is a half. X, I'm not going to put that as anything right now. And P is the one that I don't know. And at this point, I'm going to sub X equals 69 because I do know that. For Y, I do know that Y is equal to 1 over square root 2. And then I need to find out what P is. So therefore, I will have 1 over square root 2 is equal to, I'm going to get rid of that 1, I don't really need it, 1 over 2 to the exponent of X is 69 divided by P. So notice, between all the methods, I'm noticing that I have a 2 on the left, 2 on the right, just looks a little different. I can rewrite that 1 over square root 2. So this is what I'm doing in my rough work, right? I'm just showing you because I can't physically show you this in the background, is that if I have 1 over square root 2, I can rewrite that as 1 over 2 1/2 because that's what it's equivalent to. And then in terms of 1 over 2, because I want to match the base, I can rewrite that so it is 1 over 2 to the exponent of a half, because both of these parts, the numerator and the denominator, would have an exponent of a half because it's okay for that 1 to have an exponent of 1/2. 1 over 2 to the exponent 1 over 2 is equal to 1 over 2 is equal to 69 over P. Step, I can now drop the base because the bases are matched. 1/2 is equal to 69 over P. I can do a quick cross multiplication and I will get 69 times 2, and then so P is equal to whatever 69 times 2 is, which is equal to 138. I need to have a therefore statement, and so I have the half-life of radium F is 138 days. For question 9, I have the following. So after an oven is turned on, its temperature T is represented by the following equation, where M represents the number of minutes, and T represents the temperature of the oven in degrees Fahrenheit. About how many minutes does it take for the oven's temperature to reach 300 Fahrenheit? Show your work or explain how you arrived at an answer. So that means I want to reach 300 F. So is that the T or the M? Well, it makes sense that it's the T. That's the temperature, right? So it's 300 degrees Fahrenheit. Meanwhile, it says to find how many minutes. So that means I'm looking for M. So nice thing is my equation is already made. And so I just need to sub in this case and try to algebraically find my M. So sub T equals 300. You will get 300 is equal to 400 minus 350, bracket 3.2, to the exponent of negative 0.1 m. I gotta do BEDMAS backwards, so that means I need to subtract 400 from both sides. I will get negative 100 is equal to negative 350, bracket 3.2, to the exponent negative 0.1 m. Next, BEDMAS backwards, I need to do my, I did my addition and subtraction. I need to do my multiplication and division. So I have to divide both sides by negative 350. Therefore, I will get 0.29 is equal to 3.2 to the exponent negative 0.1 m. So again, this is a case that you would do the trial and error way or the log way. And log, the base becomes a base, the output becomes the input, and the input becomes the output. Again, I need to do a little conversion, so I get log 0.29, that's part of the numerator, divided by log 3.2. is equal to, just leave the right side as is, and you get equals negative 0.1 m. I need to get my m by itself. At this point, I'm going to divide both sides by negative 0.1, and I will be able to get like a very close answer to the exact. So I like doing log 0.29 divided by log 3.2. I don't write down the decimal value of what that is per se, because I like leaving that all in the calculator, and then I'll times that whole thing by 1 over negative 0.1, or log 0.29 divided by bracket negative 0.1 times log 3.2, close bracket. And when you do that, you should be getting 10.6 approximately as your answer. Very important that you are getting this actual value on your calculator, because if you're inputting it the wrong way, the numerator and denominator is interpreted differently, brackets are missing or whatever. If the way you're inputting it is wrong, you might be getting different answers. So I do invite that you try this out on your calculator, especially for our notes, and then you're getting that exact answer. And therefore, it will take 10.6 minutes for the oven to reach 300 degree Fahrenheit.